Hello, this is Iben from Spirent. Today we're going to be talking about performance, specifically how to scale out your NFV implementation. We've been doing a lot of testing in our new virtual cloud test lab, which is available online to NFV vendors and vendors, interested enterprises and customers who are looking to adopt it. And we've learned a few things in the last few months as I'm pretty new to the company. As we've been getting our test lab set up, I wanted to share some of our. I'm a principal architect dealing with cloud and virtualization at Spirent. I've been there a few months, but just wanted to thank you for coming today. Oh, and by the way, for the recording, this was recorded on October 16th, 2014 at the SDN World Congress in Dusseldorf, Germany. All right. So here to tell you a story about my experience. Like I said, I've only been here a few months, so we're just going to go through this pretty quick and give you some background on virtualization, SDN, what we've learned about the decision-making process and how companies adopt technology, and then we'll be sharing the lessons after that. As you all know, I stole this slide from my buddies over at SDN Testing, and they've been doing a lot of research into this area. As you know, seems like everyone's adopting SDN technology. As a matter of fact, we've done a survey recently. This survey is already out of date. It shows that over 50% of the companies are going to be evaluating SDN or NFV technology by the end of the year, and that's actually gone up to 90% from the latest survey. So things are moving pretty quick. Many of you work for service providers, and there's some very important things that you consider when you're deploying a new type of technology in your environment. SLAs, you can't really afford to have dropped calls. You also have to be able to steer traffic through the correct path, service chaining. Also different types of traffic to go through different parts of the network depending on video or voice, depending on the quality that you're trying to achieve. You can't have any drop packets. Financial data, for example, that has to be very low latency, high frequency trading. So you're looking at this new technology, you're learning about its impact, you're being persuaded probably by different business units or financial concerns in your company. Everyone else is doing it, and you're going to make a decision as to which technology to adopt, probably start a POC, a point of proof of concept implementation, and then you go through to a full-blown pilot project and implementation in your production environment. What typically happens, depending on your company, is you're looking at the different types of companies are more willing to accept risk, and they're going to be either the innovators or early adopters. And then there's the companies that are more conservative and like to wait till everybody else figures it out, and they're going to take a look at the technology later on down the road as it matures. They don't want to take that risk. There's another way of looking at it. A little funny cartoon I found that sort of illustrates the same thing. Mark Casado's actually talked about this in his work at VMware with the NSX product. It's ramping up really quick. He said over 40% of the adopters for SDN technology there at VMware with the NSX solution are using software-defined networking, specifically network virtualization, to solve a security use case, to implement microsegmentation in their larger clouds. This allows them to overcome the limits of VLANs and gives them more flexibility for their investment in their firewalls, physical firewalls. So we see more and more virtual solutions coming down the pipe, and with the virtual, there's a lot more uncertainty depending on what hypervisor you're running. You need to be concerned with performance, security, and reliability. And then how do you manage it? As you scale out these implementations, there's going to be the need to not just deploy a couple big firewalls, big iron that you used to. You take them out of the box, put them in the rack, and wire them up. But now you're doing hundreds, possibly, or thousands of virtual firewall instances in your cloud. So you definitely need to automate those installations, and then you have to keep those maintained. So there's a lot of DevOps tools now coming along probably already heard of Puppet and Chef, and there's other popular tools like Ansible and Salt people are using to manage those environments and keep them running after they're deployed. So what are some typical use cases? Where are people putting, we're taking an example, these are from Intel. They had their Intel Developer Forum recently, and I like the way they presented this. So in the data center, in your typical access network, there's going to be different layers of routers that can be put into your network. So you have access layer that the customers are using. There's the edge, which is out there in the border gateway and the metro POPs. Of course, there's going to be the core of your network. And then there's the back end where the data centers interconnect or the switch network. So we typically see the virtual router solutions going into these green areas. That's going to be more in the core. Not always the core router. If we need a lot of mesh bandwidth, that might not be the right fit, although we see some improvements going there. But more on the edge and data center, in between data center, embedded in the data center. What's the impact of virtualization here? Well, all these, no matter where you're going to deploy your routers, if we're talking about a router in this situation, it could be in your cloud, in your edge, for mobility. There's some common impact that you need to look at. So we've taken sort of the core feature set and looked at these dependencies here. So service chaining, the elasticity, being able to provision up and down on demand. That's where the orchestration comes in. Availability, if there's redundancy that's provided. Being able to migrate workloads from one hypervisor to another if you need to do maintenance or if a hypervisor is starting to have issues, hardware issues. And obviously being able to support multi-tenancy where you can have multiple vendors. I always use the example of Pepsi and Coca-Cola should be able to share the same cloud infrastructure because the security is so good there that they will be protected from each other. Testing for service provider, cloud data center VNFs. So there's different types of testing that you can do depending on where you're looking to put these VNFs. A VNF is a virtualized network function, and it falls under the NFV category. So you have network function virtualization as a market segment in whole. But inside the NFV family are many different VNFs. So again, we're talking about routers in this example, and we're going to need to do layer 2, 3 testing for the routers that are out at the edge and core, whereas the router devices that are being used for mobility, this is going to be your virtualized EPC instead of just routers. There's a lot of other EPC equipment that goes out there. And then inside your data center, we do a combination of testing, including layer 2, 3, and layer 4, 7. So as many of you know, we've been looking at new ways to orchestrate the deployment of the products out, virtual products out in the cloud. And OpenStack is one of the more popular cloud solutions that is being used. I don't know how much it's being used in production, but definitely it seems like almost everyone's talking about using OpenStack in a development environment for their testers. And I'm sure there are a number of production OpenStack deployments actually going on now. There's even a number of commercial OpenStack distributions that you can purchase. So they're all actually fairly new, though. So you see Red Hat and HP are two of the popular ones. I think HP's is still in beta, but they'll deploy it for you and help you support it. So OpenStack's definitely taken off, and that's where we've seen a lot of focus. I wouldn't say it's the predominant cloud solution at most of our customers. Many of our customers have already built their own cloud-based management solutions for infrastructure management years ago, even before OpenStack came along. So we have to support those too. But as we do development and testing new products, we're definitely looking at seeing how they can work with OpenStack. So that goes along with the test methodologies and the tools that we use to deploy those products into the cloud. using OpenStack. So that's basically our reference platform, and then we can adopt that with REST APIs to pretty much any cloud solution. We have a number of protocols that we support, thousands of different protocols that we can either test or emulate to exercise your equipment, and we can verify that the segment routing is working properly, and then we deploy these products on different hypervisors as virtual firewalls, gateways, and other types of DNS. So like I said, I'm pretty new to Spirent, but I was pretty excited to learn about what types of testing hardware they have available. And while they do have, I came on board thinking it was pretty much a lot of the virtual test solutions. It's my title, right? Cloud virtualization guy. Their legacy goes way back, and we have mastered the science of testing network equipment. So we are just releasing these new 100 gig modules with new form factors, and we're working with a lot of the equipment vendors to make sure everything's compatible and accurate and working well, and that the equipment performs as expected. So we're building a virtual cloud test lab. It's actually already out there on the internet, available for use, and we've actually just done our first test with it. We did a test of the Brocade, the auto router, and we're looking for other customers that could potentially test their products in our lab. And we're using all this latest technology there to do this testing. The technology doesn't work by itself. We need really smart people to make it work. But what we're doing is picking their brains and actually taking those methodologies that they have and programmatically implementing them into the cloud test system so that these test methodologies can be done automatically by someone who doesn't have that expertise, someone who isn't experienced in some of these new technologies, but still wants to verify that the products they're looking at will meet the requirements. This is an example of a new protocol test that we've implemented, and we can, how many of you are using DHCP today? So I'm sure many of you want to or think you need to, but you probably haven't gotten too far on those projects. Probably a couple that have been doing a good job on it, but it's a huge investment, and you're not quite sure when it's going to pay off because it's hard to monetize that. But it will definitely set you up to be prepared for future growth. So here's an example of a test, DHCP multiple addresses test. DHCP v6, sorry, version 6. IPv4 is running out of IP addresses. So we need to migrate to a dual stack technology on most of our equipment and make sure that it supports not only the legacy IPv4 but also IPv6 networking. And it's been a challenge to test for that because not everybody is supporting IPv6, and we've come up with some new tests that allow us to do that. So you put your product into the NFV benchmark factory that we have. We will verify that it's working properly for all the different protocols that you're supposed to, that you want to support. Basically validate the data sheet and ensure that the performance is there, the security is there, and that the protocol support is there. So here's another example test that we can do. If you're supposed to, if your product that you're looking at is supposed to support high availability failover in case of a hardware issue, then you want to make sure that you can have active-active routing where traffic goes through both devices in parallel during normal operation. But if there's a hardware failure or a link failure, that the traffic will seamlessly shift through the second device, the backup device or alternate device. And how does that work? So you can test those protocols and look at the BGP and OSPF protocols and see how the devices interoperate, both in a failure mode, so as the device fails, but then also when you bring it back up and you want to start using the two active nodes again, make sure that the failover and failback are both working properly. And if that's not enough, we have just released a Jenkins plugin, which allows us to actually automate all these tests that we've talked about, even building the topology to run the test. So deploying the VMs, configuring the VMs, running the test on the VMs, and then taking the data from the report and publishing that report to automate all of that. And we're storing these in a source code repository, so you can use Git, Subversion, another type of database, and drive that through Jenkins triggers so that when you have new builds of products, or if you're doing configuration management through Jenkins, then those configs or product changes can trigger an automated test and provisioning of the topology. So that's pretty cool, and that's one of the things that we're really excited about. It allows us to take those methodologies created by the smart people, have them run by somebody like me, and have it run automatically even while I'm sleeping. So I just love that, being able to do my work for me. Here's some of the things that we found that we need to look at as we're doing this testing. As you know, a virtualized network function runs on top of a hypervisor. There's typically a vSwitch in the middle, although we have implemented VNFs in bare metal without a vSwitch, and maybe even without a hypervisor, where it just uses all the resources of the hardware, and that way it can talk directly to the PCI bus and the network interfaces. So if you're dealing with performance and you're concerned with the throughput of the box, you need to look at a number of metrics from, typically it's a Linux operating system. So from the Linux OS in the kernel, you're looking at CPU wait time, memory utilization. We even assess the power utilization of the system under test, and then look at storage metrics as well. We want to make sure that we have identified all the bottlenecks and that we know where, if we need to improve performance, where we can focus to allocate additional resources. It's pretty complex vendor landscape. We have a lot of different products to deal with, and at each layer of the stack, we have options. So we can swap out the vSwitch. There's all sorts of different vSwitch vendors dealing with Open Virtual Switch. We have Cisco, IBM, and others that want you to adopt their virtual switch. And there's different reasons why one would be better than the other for a situation. Of course, there's hypervisors to deal with. There's the popular ones that we have to choose from. Everyone's probably got a VMware installation in their data center somewhere, but a number of customers are looking at alternatives to VMware and working with KVM due to its open source nature, or Microsoft Hyper-V now has changed their licensing model in 2012 to allow you to use Hyper-V for free as a hypervisor, and it makes it a very popular choice for cloud providers now. There's also online cloud vendors that allow you to put your products into the cloud on Amazon. You can actually migrate your VMware workloads to Ravello, for example, and have them run without any hardware, just right in the Amazon cloud. So you're just paying for the CPU and memory resources out there in the cloud on an hourly basis. So more efficient if you just have some short testing to do, or a lot of tests, because that way you can run many things in parallel. Service chaining. These are very complex topologies to set up, but once you've programmatically implemented it with the code, you can then deploy that program to implement it almost anywhere. So it gives you a repeatable process, and even though it is complex, you're ensured that it will be accurately deployed over and over again every time you need to do it. So that's a big benefit for the type of testing that we're doing, where we've automated the topology deployment and testing. So we have a success story that we, like I said, we had a blog that was just published, a report. You can read the blog about the report that we did. We did a test for Brocade in our lab, and this is the Viata 5600, which was tested in the VCT lab. And they've got some, I like their drawing. So they're out on the POC floor, and they show how using multiple CPU cores can increase the performance of the VNF. So obviously having fewer CPU cores would reduce the packet processing performance, and adding additional CPUs increases performance. It seems like that would make sense, right? Like I said, they're out there on the POC, the ETSI NFV POC environment, so go out there and see their booth. there's a number of use cases that you can go check out, and I suggest you stop by if you have time later. So here's an example of Python script I've written that gives us a list of tests we need to run based on different scenarios that we're interested in. So in this example, there's 3 different types of environments I want to emulate, and there's going to be different hypervisors I want to test those environments. So dev A, B, and C could be maybe a different hardware solution. So let's say I'm testing Dell, HP, and Supermicro maybe, or different Intel CPUs, and I want to run these hypervisors on those different environments. And I want to test how it would work with different, these are neutron plugins that we can use, so different neutron networking stacks. So VXLAN, GRE, VLAN, local, and flat are the options I have here. And for each of those, I want to iterate through and try the Linux bridge, the Open vSwitch, Nexus, and Arista drivers. So just writing a simple script like this with a few parameters takes me to a list of tests I need to run that has over 400 different iterations. So I'll need to loop through 400 different tests and get the sweet spot of the results as to which performance I want based on security and hardware and hypervisor compatibility based on my stack choices. So there'll be 400 different test reports I need to look through. And one of the things we're doing is analyzing these tests with big data analytics and graphing it, and then doing trending. So we're going to be repeating these tests over and over every day, every week, as we need to, as new builds of the software come out, and make sure that we track the performance improvements or even security vulnerabilities coming from these products. Now we're going to shift over to the lessons learned. As we talked about, obviously adding more CPU power can increase throughput. So we started off with a simple test where we had one CPU core, one DUT, not one CPU core, one CPU socket. And in this example, we allocated 8 eCPUs to the DUT, which is a router. And we were using 4 network cards. These are 10 gig network cards with 2 ports each. So we have 8 total 10 gig ports. So we used 4 for traffic in, which would be the client side, and then 4 for traffic out, which we call the server side. So we're sending traffic from the client to the server and back and forth, and we're measuring the performance between the client and server. So in this situation, we were able to get decent performance, and everything kind of worked as expected. We didn't get the full utilization of the hardware, obviously. And because of the NUMA bus, memory is split and shared across the CPUs through a bridge. So we're only really using half of the hardware resources of the server. So we said, hey, okay, well, what would happen if we added a second DUT and shifted the traffic over to that? So we called up the service provider and said, hey, can you plug in the other network card, and we'll add a second DUT. And now we get a situation like this, and you can see we're maybe getting a little better performance, but we're not really fully utilizing the second CPU. It's not balanced. So our performance didn't increase that much, and actually it introduced some latency because of the back and forth. So one of the options we ended up with was the topology like this. We're able to really balance the load across both processors, and we saved some CPU resources for other workloads that we want to run on those boxes. So we'll run these tests 3 different ways and get the results, probably more than 3 ways, and collect the results based on different configurations. Now we're able to actually change where the wires from the traffic generator that you see pictured on the bottom, where the wires get plugged into the network interface cards on the servers, which are the DUT servers, the device under test servers, using a MRV optical switch. So those are some of the tricks that we have in our test lab to allow us to dynamically share that test equipment between different devices under test. So I mentioned Ravello earlier. The vision, where does this take us all? The vision we have for the future is something that's actually being implemented now is many of our customers have a Spirent test lab, a test lab in their environment where they have Spirent other tools, obviously, and they are testing their products in the lab. But they're not really able to take those tests and move them out into the production environment, and it's not real world. So the developers aren't really testing their products, and it's once the product's released, and we're actually considering an implementation, if you go back to your decision-making process and your technology implementation curve, that's when you start thinking about testing it. Well, we want to change that. We want to make testing something that developers can do. And so we're plugging into the developer pipeline with the CI integration tools like Jenkins and giving you now the ability for your developers to have their products tested at day one as they check in their code and throughout the life cycle of the product as it goes into production. So that's our story. Thank you for listening so far. And we're going to open it up for questions now, if there's any questions.